In this video, I'll show you how to solve the ALEKS problem called Understanding Pressure Equilibrium and Atmospheric Pressure. So this problem is going to give you a sketch of an open tube. It's open at this spot right here, which means that atmospheric pressure is pushing down inside this tube on the mercury that's inside this little glass whatever it is. And then we also have a closed tube, which means that this is closed off, so atmospheric pressure does not come into consideration in this particular situation. And it's asking you to slide these little buttons around to decide what these glass container things will look like when it finally stops, when the mercury finally stops moving around. So the relationship that we need to think about when we're solving this problem is actually the relationship between the pressure units, atmospheres and millimeters mercury. And you've probably learned that 1 atmosphere is equal to 760 millimeters of mercury. Because this particular device is measuring in units of meters, it's going to be useful for us to convert this into units of meters, which we would do just by dividing by 1,000. So 1 atmosphere is 0.760 meters of mercury. And that is referring to height, that it goes up or down in a column like this. Okay, so we're going to keep this in mind, and we're actually going to work with the closed tube situation first. So inside this closed tube, it tells us that there's this gas up above. This gray stuff here is the mercury, and then there's this gas up in this area up above, and that gas has a pressure of 2 atmospheres. And if we convert that 2 atmosphere pressure into millimeters of mercury, to do that, we would just use this relationship right here. So 2 atmospheres, multiply it by our conversion factor, 0.76 meters. I'm going to leave the mercury symbol off. 0.76 meters is equal to 1 atmosphere. So this is going to be, I'm not going to use the calculator, this is just going to be approximately 1.5 meters, which means that the 2 atmosphere pressure pushing down on the surface of this mercury is going to cause the mercury to rise up the column by about 1.5 meters. Now, before you get excited and choose this 1.5 meters as your answer, that's not the answer. Keep in mind that if there was no pressure inside this at all, so if this was a vacuum, then the level of mercury inside this little bulb part would be equal to the level of mercury that would be up inside this little tube. So the mercury would just sort of kind of equilibrate in terms of the level. It would, if I could kind of color it, it would look kind of like this. So the level of the mercury would be at the 1.5 spot level right here. And so this is where it would be, this would be kind of like its resting state if there was 0 atmospheres inside this little vessel. But since we have the 2 atmospheres inside this little vessel pushing down on the mercury, it's going to push that mercury up this particular column, and it's going to raise it up by 1.5 meters in height. So that mercury, some gray here, that mercury is going to rise itself from 1.5 meters, which is kind of its resting spot, up another 1.5 meters, which is going to bring it up to a height of 3. And so for this particular problem with the 2 atmosphere pressure, that gas is going to push itself up to the 3 height. So pay attention to what the unit is in here, or the amount of pressure is in here, because this does vary. And then whatever it is, convert that number into meters of mercury, and then add that to the 1.5 position, and that's going to give you the final height. This is for the closed tube. Now the open tube situation is a little bit more complicated. And again, in the open tube situation, so mercury level right here, this is what the mercury level would look like if there was no gas pushing down from here, and also if there was no gas pushing in this open end of the column as well. This is where it would sit. But we do have gas inside here that is pushing the mercury up the column. Same number, same 2 atmospheres, and we've already done the math on that. So those 2 atmospheres are going to raise that gas up by another 1.5 meters inside this column. But here we also have to take into consideration that this is now an open tube, which means that the atmosphere is going to be pushing down on the gas as well. And I'm trying to see if it tells us anything about the pressure of the atmosphere. I don't see that anywhere in here. So we're going to assume that the pressure of the atmosphere is pushing down with a unit of 1 atmosphere, which is pretty standard for atmospheric pressure. So the atmosphere is pushing down 1 atmosphere of pressure. 1 atmosphere of pressure is 0.76 meters of mercury. So that atmospheric pressure is going to push the mercury back down by 0.76. And what we need to do is subtract that. I'm just going to call it 0.8. From the height of the mercury. So again, the 1.5 meters is where the mercury would be sitting if there was no pressure inside the bulb and no pressure outside the system as well. Not necessarily 1.5, but it would be sitting level. These heights would be level. The pressure inside the bulb is going to push the gas up, and specifically it's going to push it up by 1.5 meters. The external pressure is going to push the gas down, and specifically it's going to push it down by 0.8 meters. And so that is going to give us, that's going to end up 1.5 plus 1.5 is about 3 minus 0.8. That's going to be about 2.2. So our gas is going to end up right around this spot right there. And again, you're going to choose this answer by kind of clicking through these different options and finding the one that has the height of the mercury that matches up the closest with the calculation that you've done.